which states an NDB is on a relative bearing of 316. So relative bearing is given to you, which is 316 degrees from aircraft. Compass heading is 270. Deviation is given. Variation at aircraft is given and variation at station is given. You have to calculate true bearing of NDB from aircraft. That means you have to calculate QTE. So let's solve this question step by step. First, we have a true heading, variation, magnetic heading, deviation, and compass heading. So compass heading is 270. Deviation is 2 degree west. Magnetic is we don't know. And variation at aircraft is 30 east. Variation at station is 28 east. Now, whenever you're doing questions for VOR, the variation is to be applied. Variation is to be applied at the VOR station. In case of NDB, the variation is to be applied at aircraft. At aircraft. So now this is a question related to NDB. So use the variation at aircraft, which is 30 degree east, which is 30 degree east. So I'm writing it here. Variation is 30 east. Now compass is 270. Deviation is west. Now if deviation west, compass will be west, meaning compass direction will be more than magnetic direction. So our magnetic heading will be 270 minus 2, which is 268. With a variation of 30 degree east, magnetic will be least, meaning magnetic will be less than the true heading. So true will be more than magnetic by 30 degrees. So it will be 298 degrees. So this is, we have found all the headings we want. Next, we have a relative bearing of 316. So relative bearing is 316. Magnetic heading is 268. Now with these two pieces of information, we can find out magnetic bearing to the station, which is nothing but your QDM, which is what? Relative bearing plus magnetic heading. So relative bearing is 316, magnetic heading is 268. So the addition will give you a value more than 360. 316 plus 268, which is 584. So subtract 360 again. So 224. Now if QDM is 224, your QDR will be the reciprocal of that, which is 224 minus 180, which is equal to 044. Now QDR is magnetic bearing from the station. The question has asked us to find true bearing from the station. Okay, from your aircraft. Correction. True bearing of NDB from your aircraft. So QTE will be how much? 044 plus variation, which is 30 degree east. Now QDR, I will write it here. QDR is the magnetic form. QTE is the true form. Both will give you bearings from the station, right? So in order to convert magnetic to true, you need to apply variation. Now QDR is 044. So QTE will be 044 plus 30 because of variation is east, which is equal to 074. Now QDM is what? QDM is 224. So its true bearing will be 224 plus 30 variation, which is 254. Now the correct option here will be calculate the true bearing of NDB. Calculate the true bearing of NDB from your aircraft. So that means they are talking about your Q, P, QT, QUJ. Yeah. So they are talking about QUJ. So from aircraft to your NDB. Okay, true bearing of NDB from your aircraft is asked. So that is QUJ. If the question would have been true bearing of aircraft from NDB, so you would have found out QTE from aircraft to NDB. So that means you're going from aircraft to NDB, you're tracking towards NDB, and that's why you require QUJ. You require QUJ, and if the question were from NDB to aircraft, so it would have been QTE. So next question. Let's go to question number 22. So you have to be careful in solving this variation deviation sum and then carefully substituting the values and applying variation and deviation accordingly. Okay. A VOR and NDB are co-located. An aircraft is equipped with an RMI. It is flying away from both of the beacons. Okay, away from VOR outbound, NDB away from NDB outbound again. So on a radial of 0 degrees through an area where magnetic variation is changing rapidly. Which statement is correct? Now very simple. Here is your VOR station as well as your NDB station, and you're tracking outbound on a track of 0. Now VOR station, the location where VOR is situated, there is a fixed variation. Where aircraft is located, aircraft will travel from one place to another place. Over here in this region, the variation is changing rapidly from place to place. What happens in case of VOR? In case of VOR station, we apply the variation which is existing at the VOR location itself, at the VOR location. In case of NDB, to find bearings, NDB bearings, we apply variation which is existing at your aircraft location. Now, as per this question, this aircraft location, aircraft will travel from place to place, and as it travels from place to place, it is encountering a variation of different values. Okay, the variation is changing rapidly. So, if variation is changing rapidly, that means the relative bearings shown by your automatic direction finding equipment will also change accordingly. So that means what it means is that the ADF needle, that is your relative bearing indicator needle, will move accordingly as per the variation change, but the VOR needle will stay the same because variation is the same. So the correct answer will be the ADF needle will move, but the VOR needle will not move because the variation at VOR location is the same, constant. But the variation for NDB, which is nothing but your aircraft variation, is changing, and with variation changing, the bearings will also change accordingly. So correct option is option delta. Question 23. If a failed RMI, if a failed RMI rose is stuck on 0. That means magnetic heading is stuck on 0, and the ADF pointer indicates 225. The relative bearing of the station will be what? So over here, ADF pointer is indicating 225. That means the QDM towards the NDB station is 225 degrees. And a failed RMI rose is stuck on 0. So magnetic heading is 0 degrees. Now what will be the relative bearing of your aircraft? So relative bearing of your aircraft is magnetic bearing to the station minus magnetic heading. So in this case, magnetic bearing to the station is 225. magnetic heading is 090, the subtraction will give 135 degree. So the correct option will be Charlie. Okay, if your RMI indicator has failed, that means what happens is uh, you will not be able to determine the QDR of your NDB station. Okay, in case of NDB, with a failed RMI, you won't be able to determine the QDR of NDB station. In case of VOR and your RMI has failed, you won't be able to determine QDM to the station. Okay, so in case of NDB, you can determine QDM. In case of VOR, you cannot determine QDM. Now here you have been asked to find relative bearing of NDB station, and for relative bearing you require QDM and magnetic heading, which is both available in this question, and therefore you were able to find relative bearing of 135 degrees. So remember this. Next, question 24. An NDB is on a relative bearing of 316 degrees from aircraft. Compass heading is 265. So let's write this. Compass heading is 265. Deviation is 3 degree west. What will be your magnetic? Magnetic will be less than compass because deviation is west. Compass will be best. Okay, if compass is best, that means compass is more than magnetic. So magnetic will be less than compass by 3. So 262. Now variation. Now here you will have two variations. Variation at station and variation at your aircraft. Now if you are dealing with a sum which involves NDB station, you are going to use variation at your aircraft. So aircraft variation is 36 degree east. 36 degree. Now variation east magnetic will be least, meaning magnetic will be less than the true direction. Therefore true will be more than magnetic by what value? 36 plus 262. So 298 degrees. 298 degrees. Okay. Now let's proceed. You have been asked to calculate true bearing of NDB from aircraft. So true bearing of NDB from aircraft means you have to find out QUJ. Now what is QDM? QDM is by formula relative bearing, magnetic bearing to the station is relative bearing plus magnetic heading. Substitute the values. Relative bearing is 316, magnetic heading is 262, 578 minus 360 is 218. So if QDM is 218, your QUJ will be what? QDM plus variation. Because variation is east, your magnetic will be least. If magnetic is least, that means your true direction will be more than magnetic direction. So QDM is 218, variation is 36, is 254. So correct answer will be alpha 254 degrees. 254 degrees. Okay. Next. Be careful about variation deviation calculations. What is the wavelength of an NDB which is transmitting on 375 kilohertz? So frequency given is 375 kilohertz, which is equal to 375 into 10 raised to 3 hertz, right? And velocity is 3 into 10 raised to 8 meter per second. So wavelength will be velocity divided by frequency, which is 3 into 10 raised to 8 divided by 375 into 10 raised to 3. When you do the calculation, the answer will be 8 into 10 raised to 2 meters. 8 into 10 raised to 2 meters, which is option D, 800 meters. Make sure you convert kilohertz into corresponding hertz. and all values SI units are in SI, that is standard units. Okay. Question 26. Which of the following is likely to have the greatest effect on ADF accuracy? That means out of the factors given here, what factors will have the greatest effect on ADF bearing accuracy? Frequency drift at the ground station, irrelevant. Interference from other NDBs, yes. Particularly at night, yes, because at night we do not have D layer and E layer. So sky wave interference with surface wave happens. Interference from other NDBs, right. So that's why we have a minimum distance separating two NDBs. We call it designated operational coverage. Okay, when you travel away from an NDB and exceed the maximum range meant for that NDB, you will change the frequency from the previous NDB to the next NDB station so as to avoid having interference or confusion of signals between both NDBs. So B looks correct. C is interference from other NDBs, right? Particularly during the day, that is wrong. Okay. Mutual interference between aircraft aerials, again wrong. So correct option is option Bravo. At night time, you have this pronounced effect of interference. Question 27. You are on a magnetic heading of 055. Your ADF indicates a relative bearing of 325. What is QDM? So QDM will be what? Magnetic heading plus relative bearing. Substitute the value. 055 plus 325 is equal to 380 minus 360 is 020. So QDM is 020. Now diagrammatically, how will you show it? So if QDM is 020, QDR will be DR will be 200. So that means here is your NDB station. This is your QDR. Track away from the NDB station at 200. Track towards the NDB station at QDM 020, right? And your aircraft is going towards the NDB station on a heading of 055. So on a track of 020 and on a heading of 055. Now what is relative bearing? Relative bearing is the angle between your magnetic heading and the track towards the station. The track towards the station. Measure clockwise starting from the magnetic heading. Okay. So like this. Now this angle will be equal to, now this complete circle would have been 360 degree, right? But we are not making a complete circle. We have stopped here. So the remaining distance, this angular distance is nothing but 55 minus 20. 55 minus 20, which is equal to 35. So 360 minus 35 is equal to 325, which is what is given in the question. 325. So diagrammatically you represent it like this. Okay. Next, question 28. Wind velocity is given in true direction. 230 at 20 knots. Variation is given to you 6 degree east. True airspeed is 80 knots. What is the relative bearing from an NDB? That to be maintained to achieve an outbound course of 257 from overhead the beacon. So that means outbound course means they are talking about tracking away from station, which is QDR 257. So QDM will be 257 plus minus 180, 077. Okay. Now you have tracked, now with the available information of wind velocity, your track, wind velocity and task, you will get your heading. Now you have to make sure the wind velocity is in true and track that you have found is magnetic. So first make this equal. So convert wind velocity into magnetic or convert track into true. Okay, it's up to you. So we will convert wind velocity into corresponding magnetic direction. So if wind velocity direction is 230 true, according to magnetic it will be how much? Variation is 6 degree east. With variation east, magnetic will be least. So 230 minus 6, which is 224 magnetic. So now using CX3, we will find the heading. So wind correction task is 80 knots. So put 80. Now course away from ADF we have to find. So track away is 257. Wind speed is 20 knots and wind direction is 224 magnetic. So you're getting a true heading of 249er degree. A true heading of 249er degree. Correction, magnetic heading of 249er degree. So now we have to find relative bearing when you're flying outbound. Okay, relative bearing when you're flying outbound. So first let's find relative bearing if we are flying inbound, because that is the formula. So QDM plus magnetic, QDM minus magnetic heading. So 077 minus 249er plus 360 is 188. Okay. So with this. Now we will draw this NDB station. The track away from NDB station is 257. The track towards the NDB station is 077. Aircraft heading is 249er. So somewhere here. Magnetic heading 249. So what is the relative bearing of aircraft? Relative bearing of your aircraft is the angle between your magnetic heading and the track towards the station. So you will have to start from here and go clockwise up to this point, which is the track towards the station, right? So now this thing is 180 degree, entire thing, and this extra amount value will be 257 minus 249, which is 8 degree. So the total R relative bearing will be equal to 180 plus 8, which is 188 degrees. So the correct option will be option delta. 28 is delta 188 degrees. So little bit different sum because here we had to use CX3. Make sure you convert wind velocity true into magnetic. Track, read the question that we have to find outbound course. So outbound course is given 257. Accordingly, you found QDM from QDR, magnetic heading from CX3, and then you use the formula, or you can use diagram wise also you can do it. Okay, simple. Question 29. QDR is 0.75. So if QDR is 0.75, automatically you can find out QDM, which will be 255. Magnetic heading is 029er. What is the relative bearing? Substitute the values. Relative bearing is QDM minus heading. So 255 minus 029er. So 255 minus 29 is 226. So relative bearing is should be 226 degrees. Let me check the question again if there is any error in copying this. So yeah, heading is 295. It's not 29er. Heading is 295. So there is an error in this question. Heading is 295. Okay. So let's substitute that. 255 minus 295, which is minus 40 degree, which is plus 320 degrees. So correct option is option Charlie. Okay, relative bearing is 3 to 0 degrees. Question 30. A VOR and NDB are co-located. You cross the VOR radial of 240 on a heading of 360. So there is a VOR and there is an NDB. So there is a radial of 240, so known as QDR 240, and you cross this particular radial on a heading of 360. So that means your plane is flying straight ahead. Okay. This is your northerly datum. Okay, so you are crossing this radial with a heading of 360. Next, in the vicinity of the station, you should read an ADF bearing of what? ADF bearing meaning your relative bearing will be equal to how much? Now, relative bearing is magnetic bearing to the station minus your magnetic heading. Now, here it's given to you that QDR is 240, which is magnetic bearing from the station. So magnetic bearing to the station will be reciprocal. So 240 minus 180 is 060. Okay, so substitute the value. 060 minus 360 is minus 300 is minus 300 plus 360 minus 300 is 60 degrees. So correct option will be delta. Relative bearing will be 060 degree or 60 degree. So again, simple radial was given and both are co-located. That means VOR and NDB are co-located. Aircraft is on radial of 240 or a bearing of 240 from these two stations, heading of 360 straight towards the north. Following the formula, relative bearing, magnetic bearing to the station minus magnetic heading. So we know magnetic bearing from the station, from that we derived magnetic bearing to the station, substituted the values and found out the answer. Very simple and scoring question. So make sure that you solve this question in the exam. Don't get it wrong. Very simple. With this, we have come to the end of this lecture. I hope you have understood all the 10 questions that I have solved today. If you have any questions, doubts, you can ask me in the comment box. I will